Okay, so we're going to talk about some special cases with horizontal lines, vertical lines, and then we're going to domain and range, and then we're going to work on writing some equations. So a little bit of everything today. So a horizontal line is a line where your slope is 0. So it's going to be y equals some type of constant. And again, a constant is a number that doesn't change. That's why it's called a constant. So y equals 2, right? That means your y-intercept is at 2. So you have a horizontal line that goes through 2. Slope is 0. It's nice and flat. If it was positive or negative, there'd be some slant to it. Well, a vertical line, the slope is undefined. So it's vertical, straight up and down. So at -3, we're going to have a vertical line. Again, this time h is the constant. So you have a vertical line. So you have positive slope, negative slope, slope of 0 is a flat line, and slope that's undefined is a vertical line. Okay, so now we're going to dive into domain and range. You saw a little of this last year in Math 2. So the domain of the function are all the x values that the function can take on. It's your input. The range of the function is the y values, which is your output. And then you're going to see also, usually when I write domain, it's capital D, range, it's capital R. With a colon, and then you list whatever the domain is. So again, some of this you've seen, but just kind of review. We're going to use brackets when you want to include the endpoint. So these are examples of brackets. We're going to use parentheses when you don't want to include the endpoint. So this would be an example. I like to call the first part these a closed bracket and this an open bracket. It's just to me easier to kind of remember it that way, open versus closed. When you're talking about infinity, you always use parentheses, so it would look like negative infinity to positive infinity, always with the open brackets. This is one that you definitely want to remember, small number to large. We're going to use a U or a union to connect intervals where there's more than one domain or range. So something could look like this, where you have multiple domains or ranges, like there's gaps in the graph. And we'll get to that in a little bit. Okay, so we're going to start with inequality notation and then go to interval. This is the one that we're going to use the most, is the interval, which you probably saw a little last year. But we'll start with the inequality notation. So the domain, those are the x values. So as you look left to right, what values of x will work? Well, if you go all the way to the left, it keeps going. It goes all the way to the right. So this would be all real numbers. So you can write all real numbers. You can use the symbol, right? Either one of those would work. Right, okay, now your range. Well, your range stops here at 3. It doesn't pass 3. So it's all the numbers below 3, but not above it. So that means y is got to be less than 3, but it can be equal to. So that will be your range. It's everything below 3. Right? Everything down here is your range. That's where you find a point on the graph. Up here at, 4, there's no point on the graph, so that's not part of the range. Okay, next one. Same idea, we're going to do domain, we're going to do range. So again, if you look left to right, every single time you call any x number, let's say we say 0, there's a point on the graph. Say 1, there's a point on the graph. Let's say, 10 out here, there would eventually be a point because it keeps going. So your domain is all real numbers. Now your range, eventually you get down here, let's say 1, 2, 3, 4, at -4 you're good, but as soon as you get to -5, there's no point on the graph. So again, the range only goes to a certain point. It's greater than -4, but it's also equal to, because at -4 there's that point. So that would be your range. It's everything above -4. So it's greater than or equal to -4. Okay, so that's inequality. Okay, now we're going to do interval notation. So that is what we were talking about up here. If you look up here where it says interval notation right here, that's what we were talking about. So now we're going to use brackets. So again, domain, right, look left to right, range is up and down. So as you look left to right, you're looking across the screen like you read, this graph keeps going on forever to the left and eventually forever to the right. So that would be all real numbers. So that would be from negative infinity to infinity. And we use the open brackets, right? It says that up there, up in the top of the notes there. The range, this graph gets really, really, really close to -5 right down here, right? But never gets to -5, right? So I don't want to write -4.9999. I'm just going to write -5. But I'm going to use an open bracket because it doesn't actually touch -5. It gets close to it. And it keeps going up forever, so that means it goes up to positive infinity. And again, you can't touch infinity, so it's an open bracket. If the graph physically touches the point, it would be a square bracket. Okay, next one. Again, domain, range. Again, as you look left to right, that's your domain. It goes forever in both directions, so all real numbers. Now look up. Let's start from the bottom and look up. It keeps going up forever and down forever, so this would also be all real numbers. Okay. So I know these two here, this one and this one, say to use inequality, but we're going to use interval for all four of these. So your domain, again, is left to right. Your range is from the bottom, right? It's from your smallest number to your largest number, so you're reading it up and down. So as I go left to right, out here is where the graph starts. So that's -5. Now, that open circle means it's an open dot, so you can't physically touch that. There's not a point there. So this would be an open bracket. If it was filled in, it would be a square bracket. Now you keep going, yep, at 0 there's a point, but right here when we get to 2, there's another hole in the graph. So when I say x is 2, is there a point on the graph? No. Okay, so we can't touch 2. We're going to have to go past 2 because the graph keeps going. So we're going to use a union because there's more than 2 sets of domain. There's not one nice whole set like we did in the last 2 problems. So again, we go right up to 2, we skip over 2, and then we keep going out here to 6. And since that's a closed dot, when I say x is 6, can you point to a point on the graph? Yes, you can. It's y is 3. So it would be a square bracket. Again, why do I have the union? Is because there's a break in the graph right here at 2. There's a hole in it. There's an open circle. Okay, so for the range, we're going to go from the lowest to the highest. So that's from bottom to the top. So the lowest it gets to is -1. Can you physically touch that point? No, it's an open circle. I don't want to include it because at -1, there is no point. There's a point at -0.9 and -0.5, but not at -1. So I keep going, right? Now when I get up here, there's an open dot. However, is there any point on the graph that is at a height of 2? Yeah, this point here, this point here. So I don't have to skip that. I keep going all the way up to that point up here, which is at 6, and I can touch that, so I'm going to close the bracket. Most of the time for us, the range here will usually not have a union. More than likely, the union is going to happen with the domain. Usually your range will not have a union. Okay, same thing, domain, range. Again, we're going to do this quite a bit in the first semester, so you can get a lot of practice at it. So again, left to right for domain. So this arrow keeps going on forever, so it starts at -infinity. When you get to -2, though, there's a problem at -2. When x is -2, is there a point on the graph? No. So I have to skip -2. So I'm going to use a union. It starts again just past -2. Keeps going all the way out here to 5, and it's an open bracket because it's an open dot. Close dot, close bracket. Again, the union is because there's a break. At -2, there is not a point on the graph. The input are the points you plug in to get a point on your graph. All right, range. So we're going to start from the bottom and work our way up. So we got 1, 2, 3, 4, 5. So -5. It's an open bracket because it is not included because it's an open dot. Keep going. Be careful though because this arrow keeps going on forever, so it goes up forever. So positive infinity. Okay, so we got our domain, we got our range. Again, left to right for the domain. The arrow keeps going on forever to the left. Again though, we get to -2, so open dot. We're going to skip it with the union. And it keeps going. Now be careful, this keeps going forever down here. Goes on forever to the right, so it's positive infinity. Again, you're going to use the unions when there's breaks in the domain, right? When you have to skip numbers on the graph. And for us, most of the time we're only going to skip 1, maybe 2 numbers, not too many. Range, right? So for the range, we're going to start and work our way up. Domain is left to right. Range is right from the smallest to the largest number. So for most of it's bottom to top. Okay, so the lowest value down here, right? We got -1, 2, 3, 4, 5. So -5. Go up. Oh, right? Be careful. Almost made that mistake here, right? Look over here. This arrow keeps going forever. So it's actually negative infinity. And it goes all the way up. It doesn't quite get to that point. So doesn't quite touch 5, but it gets really close to it. Right, it gets to 4.999. I don't want to write 4.9 repeated, so I'm going to write 5. So this notation means that your range gets really close to 5, but it doesn't get to 5. If it was a square bracket, that means it would touch 5, and it does not. Okay, last one, domain, range. Again, left to right, so we got 1, 2, 3, 4, 5, 6. And -6, it's a closed dot, so it's a closed bracket. But if we look there at -4, we're going to skip that. So we're going to use a union. And it keeps going after -4. Why are we skipping it? Because of the open dot up there. So it keeps going all the way out here to +7. And why is that an open bracket? Because at 7, is there a point on the graph? No, there's an open dot. That means there's no point. Your range, right, starts at the lowest point. So now I'm just switching colors here, make it a little easier to see. Right, here's the lowest point. So 1, 2, 3, 4, so -4. Why is that a closed bracket? Because that's a solid dot. Is there a point on the graph at -4? Yes, there is. Okay, keeps going up, all the way up to here. So that's 6. And why is that an open bracket? Because is there a point that reaches a height of 6? No, it's an open dot. That means it's not a solution. You get up to 5.999. Don't get to 6, so it's an open bracket. Okay, so domain and range. All right, next, writing equations. So we have our linear functions, our linear absolute value, and so forth. So linear equations, usually it's y equals mx plus b, right? You can do that. You can do point slope form, right? Which is y equals m times x minus x1 plus y1. Right? But we're going to use this one because you know the y-intercept. So the y-intercept, which in this case would be b, is 0. So all I need is my slope, which I get from here to here. So 1 over 3. So it's a rise of 1, run of 3. So the y equals 1/3 x plus b. I will use this a little bit later in some equations. So if you know the y-intercept, you want to use slope-intercept form. That's the easiest way. Okay, absolute value, y equals a absolute value of x. Right, talked about this in the last note. So a is our slope, right? It's centered at the origin, 0, 0. So now all I need is my slope. Well, pick the 2 points they give you. Find the slope there. That's 2, 4. So it's 2 over 4, which is 1/2. Oops, sorry. It is rise over run, so it's at technically 4 over 2, which is 2. Makes a little more sense to the graph. So as you go through and do these equations, you're going to know the general form is right here. I'm going to write that general form first, and then I'm going to fill in the missing letters. Here, all I need to know is a. That's the slope. I don't need anything else. Here, I needed to know the slope and the y-intercept. That wasn't that hard to figure out. Okay, quadratics, y equals ax squared. So out of those three variables, 1, 2, 3, which one do I actually need to know? I just need to figure out a, right? Because it's centered at the origin. It hasn't been shifted. So I just got to figure out a. Well, what if I could replace x and y with numbers? Could I solve for a? Yeah, I could. So I'm going to use this point. So what do you got? 1, 2, 3, 2. So I'm going to use the point 3, 2 to solve for a. So this is x, this is y. So 2 equals a times 3 squared. So 2 equals 9a divided by 2. Divided by 9, divided by 9. So 2/9. So your equation is 2/9 x squared. So I solve for a by using the other point that was given to me. The vertex helps me get the original equation. That helped me to know that it looked like this, because it was at the vertex, 0, 0. This is the origin. Then I plug the point in for y and x to solve for a, and then that's all I need. So for exponential, it's y equals b to the x. Again, same concept. Since it hasn't been shifted, that's why I know the equation looks like this. How do I know it hasn't been shifted? Because it goes through the key point 0, 1. So now the only letter I technically need to figure out is b. Well, if I can solve for x and y, then I can solve for b. So I'm going to use the other point here. So that's 2, that's 3. We go 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8. So this is x, this is y. So 8 equals b to the third. So what number do you cube to get 8? That would be 2. So your equation is 2 to the x. So when you're doing exponential and quadratic, this is the easiest way is what's the general equation? And then solve for either a or b. Up here, it's just a lot easier to use the slope because they're linear, and that's what's nice about linear functions. Okay, so now we're going to practice some. So it's a linear function. So again, y equals mx plus b, right? You know the y-intercept is 0, and so we need the slope. It's going to be negative, right? So it's negative 4 over 1. So y equals negative 4x. Oh, the slope is 0, right? So m is 0 in this case. The y-intercept is negative 3. So your equation is y equals negative 3. Again, linear, absolute value. So remember the general equation is like this. So I just need a. I need the slope. Use the 2 points that are given to you. So that's 2. Right, rise of 2, run of 4, so it's 1/2 absolute value of x. It's negative because it opens down. Again, general form, y equals a absolute value of x. Again, since it's centered at the origin, that's why I know it looks like this. So now I just need a, which is the slope, so over 2, down 2. So y equals negative 1 absolute value of x. So with the quadratics, right, we know the parent function's ax squared. We need to figure out a, so we're going to have to use that other point. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So -4, -5. So -5 equals a times -4 squared. Right, so -5 equals a times 16. So -5 over 16 equals a. So y equals -5 over 16 x squared. Right, kind of weird looking equation. Same idea, y equals ax squared. All I need to know is a. So I'm going to use this point here to help me figure out a. So over 2 and up 1, 2, 3, 4. So 4 equals a times 2 squared, because this is x, this is y. Plug them into this equation right here. So 4 equals a times 4, so a equals 1. So y equals x squared. And then your exponential, so y equals b to the x. So I need to figure out b, so I'm going to use this point. I use this point to get this part. I know it hasn't been shifted. You're going to see as we write equations later, they're going to be shifted. So this part in the box is going to change. So this is your x, this is your y. So 27 equals b to the third. So b is 3, because 3 cubed is 27. So y equals 3 to the x. Same idea, y equals b to the x, because it goes through 0, 1. If it didn't go through 0, 1, that would change my equation. We'll get to that later. So then again, here's your x, here's your y. So 100 equals b squared. So b equals 10. So y equals 10 to the x. And there you go. So quite a bit there, right? Some special cases, domain and range, and starting to write equations. Please make sure that you answer the essential question when you write your summary.